All right, now we're going to see if we can use the same givens, mu 24, sigma 2.5. Let's find the 30th percentile. See if we can find the 30th percentile. All right, so picture as usual. All right, let's talk about this detail. We want the 30th percentile. Suppose we wanted the 50th percentile. The 50th. What does that mean? The 50th percentile has 50% of the data to its left. Is it clear the 50th percentile would be precisely the mean, because there is precisely 50% of the data to its left? If we want 30% to the left, that's going to have to be even less. Is it clear? That's going to need to be over here somewhere, because then this would be 30%, which is less than the half, less than 50%. So here's the moral of that story. If the percentile you seek is less than 50%, that number must lie to the left of the mean. If the value we want is greater than, if we wanted the 75th percentile or the 90th percentile, that's bigger than 50%. Anything greater than 50% lies to the right of the mean. In just a moment, we're going to work together. We're going to work out the 80th percentile. The 80th percentile, is it clear? When we get there, the picture will look like this, because 80% is more than half, 30% is less than half. Anything less than half lies to the left, anything greater than half lies to the right. All right, so now we have our line in the correct position, arrow always goes left, and we need to translate 30th percentile becomes 30%, becomes 0.30, becomes 0.3000, and that's the number on the arrow. 30th percentile, 0.3000. Do we see what that's going to eventually become? We'll see that in the next example. All right. Now what do? Now we find 30.3000 in the body of the table, and then we look out to see the z-score it came from. So I have just one this time. So that's our procedure. We need to find 0.3, oops, wrong table. We need to find 0.3000 in the body of the table. Usually it's best to look vertically until you get close. 29.33, that's close. 29, 29.12, 28, I need to get closer to 30. 29.81, 29.46, this is getting closer. Here we go. So this is the number we're looking for. We want 0.3000. That falls between. Find the two numbers between which this falls. The two numbers between which that falls. Let's zoom in once so we can see it a little better. Find the two numbers between which that falls. In this case, 0.3015 and 0.2981. Find the two numbers between which that falls. So I'm going to come back to my original work and translate this over here. 0.3000. Find the two numbers between which that falls. 0.30 and 0.2981. All right. Which of those is closer? Well, this is off by 15. You can see this is off by 19. This is off by 19. If you added 19 to the 2981, you get 3,000. So this is off by 19. This is off by 15. This is the closer. Don't always choose the larger. Don't always choose the smaller. Always choose the one which is closer to the number we're looking for. So in this case, this is the closer, and you look outward to find the z-score that came from, the 3015, that would have come from, you can look on your z table, negative 0.52. The z-score is negative 0.52. That's the z-score, negative 0.502. That's the z-score this came from. That goes here in our picture, negative 0.52. All right? The last piece is to look to find the x value that came from. So, our last piece, z is equal to x minus mu over sigma. Z we know, negative 0.52 is equal to, don't know yet, minus originally given values. Cross multiply. And solve. So I do my computation. I have, on clear, I have negative 0.52 times 2.5. As you hear the lawnmowers outside, that becomes negative 1.3. And then add the 24 across. And that gives the 22.7. That is what I just find, the 30th percentile.